So today we will discuss PN junction diode. So what is PN junction diode? When a p-type semiconductor is joined to an n-type semiconductor such that the crystal structure remains continuous at the boundary, the resulting arrangement is called as PN junction diode or a semiconductor diode. So as you can see in this diagram, on left side we have a p-type semiconductor and on right side we have n-type semiconductor. So in p-type semiconductors we have holes as majority charge carriers. We have mobile holes, and these mobile holes are denoted by these black dots, and these blue colored circles are immobile negative impurity ions. Negative sign is for negative charge on immobile negative impurity ions. And on right side, on n side, these pink dots shows mobile electrons or majority charge carriers, and green circles show immobile positive impurity ions. So on the left side we have holes as majority charge carriers, and on the right side we have electrons as majority charge carriers. So when we place these p and n type semiconductors in this manner, a PN junction diode is formed, and the p region has mobile holes and immobile negative charged ions, and n region have mobile electrons and immobile positively charged ions. And this whole arrangement is electrically neutral. Why? Because as the semiconductor crystal is electrically neutral, it have equal number of electrons and protons, and when we add a electrically neutral impurity for making that semiconductor either p-type or n-type, then the whole arrangement itself will remain electrically neutral. So we add trivalent impurities in for making p-type semiconductor, and we add pentavalent impurities for making n-type semiconductor. So impurity atoms are also electrically neutral, and semiconductor crystal is also neutral. Therefore the whole arrangement is electrically neutral. And in this diagram the minority charge carriers are not shown. This is just for simplification purpose. Actually in this crystal or in this diode there are minority charge carriers also. On p side we have electrons also, free electrons also, or mobile electrons, and on n side we have mobile holes. So there are both types of charge carriers on both sides, on p side also and on n side also. For simplification here we are showing only the majority charge carriers. Now when the PN junction diode is formed, the electrons from n side and the holes from p side will diffuse across the junction, and a electric field is set up across the junction. So as you can see, the electrons from n side and holes from p side diffuse across the junction, and they combine with each other. And on the n side we have positive ions, and on p side we have negative ions, and these ions are immobile. So when the majority charge carriers diffuses across the junction, they leave behind the immobile ions, and the region near the junction in which these immobile ions are present is called as depletion region. And because of these immobile ions there is a electric field set up across the junction. The electric field has the direction from positive to negative as shown in this diagram. and we can understand this by assuming that there is some fictitious battery is connected across the junction. On the N side we have positive ions, on the P side we have negative ions. So we can understand it by assuming that N side of junction is connected to a positive terminal of battery and P side is connected to negative terminal of battery. So after the PN junction is formed, holes from P region diffuse into the N region due to difference in their concentration. So the diffusion of electrons and holes across the junctions takes place because of difference in the concentration of charge carriers. Secondly, the free electrons from N region diffuse into P region due to same reason. The reason is same because of difference in the concentration. Third is holes and free electrons combine near junction. As you can see in the diagram, the electrons that are coming, or we can say the electrons which are diffusing from N side to P side, they combine with holes on P side, and each recombination eliminates an electron and hole. As electron and hole recombine, so the electron hole pair is eliminated. Fifth is the uncompensated negative immobile ions in the P region do not allow any more free electron to diffuse from N region. As you can see, after some time the diffusion of charge carriers from one side to another stops because on P side we have negatively charged immobile ions near the junction, and these negatively charged immobile ion will not allow the further diffusion of holes to N side, and the positively charged immobile ion that are present on N side will not allow the diffusion of electrons from N side to P side. And the uncompensated positive mobile ions in N region do not allow any more holes to diffuse from P region. The positive donor ions in the N region and the negative acceptor ions in the P region are left uncompensated. So the region containing the uncompensated acceptor and donor ions is called as depletion region, because this region is devoid of mobile charge carriers. So as you have seen in the previous diagram, that the region where the immobile ions are present is called as depletion region. Why it is called as depletion region? Because it is depleted of the mobile charge carriers. It does not contain any mobile charge carriers. It is depleted of mobile charge carriers. Since the region is having only immobile charges, therefore this region is also called as space charge region. So the region of depletion layer is also called as space charge region. And next is the N region is having higher potential than P region. So the electric field is set up across the depletion layer or across the junction from positive to negative, or from N side to P side. So the difference in the potential between P and N region across the junction makes it difficult for the holes and electrons to move across the junction. This acts as barrier and hence called potential barrier or height of the barrier. And the physical distance between one side and the other side of barrier is called as width of barrier. Next is the potential barrier for silicon is approximately 0.7 volts, and for germanium it is 0.3 volts. So the potential barrier opposes the motion of majority charge carriers. So initially when the junction is formed, the majority charge carriers will diffuse across the junction, but after some time this diffusion of majority charge carriers will stop because a potential barrier is set up across the junction, and this, because of this potential barrier, the diffusion of majority charge carriers will stop. But few majority charge carriers which have higher energy can diffuse across the junction because they have enough energy to overcome the potential barrier, and the potential barrier that is set up across the junction will help the minority charge carriers to move from one side of junction to other. The electric field that is set up across the junction because of diffusion of charge carriers will help minority charge carriers to move from one side of junction to other, and this current, the current because of movement of the minority charge carriers in opposite direction is called as a reverse leakage current. Okay, thank you students.